Hey folks, welcome to another episode of ASP.NET Core from Zero to Overkill. In this episode, we'll continue our event-driven integration journey with within the topic of storing the events in the outbox table. So, as in the past episode, we detected those events based on EF core changes. In this one, we'll do the next step, which is storing them in the outbox, where we'll start by creating the outbox table to store the events. Then we'll model those events, some classes to be able to store them. We'll build upon those event detectors we created earlier to map those changes into events, and finish up by storing the events in the database in the transactional manner, so when the changes occur, events are also stored. And before continuing, the usual plugs. If the videos are being useful, considering dropping a like, sharing, and leaving some feedback. And for more information, you can visit the blog. There's always a post that goes with these videos. Otherwise, you can reach out through Twitter or other contacts which are present in the blog or in the website. And with that out of the way, let's get started. So, before going into the code, just to see where we are. So in the past episode, we did the part of detecting the changes when the user is created from the user manager. And in this episode, we'll go into this part. So we'll do the part of creating the event based on those changes and storing it on the outbox table. So this is where we are in this diagram. Let me just go back to the topics so we follow them. And let's begin with the outbox table. So let's go here into Rider. And as you know, for modeling stuff with the EF core and doing code first, so we create a new class, which is the outbox message, which represents the entity that will be stored in the outbox table. It's a pretty simple class. We just need an identifier, as usual. We store when the message was created, just for information. And we have here the actual event, which is a base auth event, where we create a hierarchy, kinda. So all kinds of events that happen in the auth service will inherit from this and can be stored in here. So let's go take a look at the configuration for this class so we can understand what's going on. So going here to this implementation of identity type configuration, to set up the outbox message. The ID, same as usual, just setting that it's the key and to use auto increment column. And then we set up the event to be stored as JSON. So because we'll see that JSON is pretty powerful in Postgres that we are using. We can do queries inside of it and so on. But we won't actually really take advantage of that, because all we need is to store the event data and then use it later. All we need is to, when we want to publish the events to the event bus, we just want to deserialize the events and push them there. So we don't need many things, but even if we did, Postgres has great support for JSON, and we can query JSON columns, not just Postgres, but Postgres specifically has great support. For instance, if we take a look here, this has these JSON and JSONB types, and we can really query things in there. And in the JSONB, we can also create indexes and stuff like that. So it's pretty awesome. So awesome that there are some abstraction libraries that use Postgres as a document database or even event store. So it's pretty powerful and pretty cool. So but we won't take advantage of that because we just want to put things in there and take out, so it might as well be a string. But because we have JSON, so makes sense we use the JSON type. And I'll come back to this comment in a minute. For this part, for the S conversion, NPG SQL, which is the provider that we use for Entity Framework to access Postgres, already supports JSON serialization out of the box. The problem is it doesn't support hierarchies, which we'll be using. So it uses system text JSON, which is a new set of APIs, but out of the box doesn't support inheritance, so I would need to do things manually. Instead, I just use Newtonsoft JSON, which can handle it. That's why we have this conversion here using Newtonsoft JSON and using these settings. So in here, by saying this, that we use type name handling objects, it means that it will store in the database the JSON, the type name. So when we are deserializing, it knows what's the actual type instead of just thinking is a base auth type, which is an abstract, but it will know what is the actual type and will be able to deserialize. And that's the reason we're using this here. We could use just because of inheritance. Otherwise, we wouldn't need this as conversion. Related to this, as briefly mentioned, Postgres has two types, JSON and JSONB. So JSON is basically like a string, even though we can do queries on the JSON, and JSONB is an optimized version, optimized binary version, which is more performant for queries. We won't use that, but that's not the main reason why we won't use it. The problem is JSONB might reorder the properties in the JSON document. Normally that's not a problem because it's irrelevant, but because Newtonsoft JSON requires or expects the type, so the property it will add here, so the type to be the first property. If it's not, it will blow up, and JSONB can reorder stuff and move the type to another place, and that's why I ended up using JSON instead of JSONB, even though in this case I should probably use JSON anyways because we won't take advantage of the other features of JSON support. And that's about it for the outbox table. Pretty small table with just 3 properties, one of them JSON to keep things in there pretty dynamic, and we don't care. We don't want to enforce great schema there because we want to be able to put their events that we'll publish later. So let's go back to the topics. So that was the outbox table. Now let's take a look at modeling the events. This part is not as well, it's not a lot of work. So we have this base auth event, which doesn't have a lot. Again, it just has an ID, which will be the ID of the actual event published, which is important to keep it in potency and stuff like that, that we'll see in later episodes. And some information about when the event happened. I left here to do about event version, which might be important. For instance, as we evolve the events, might be important to keep an idea of this was the V1 of the event. In the future, V2 might introduce other properties, and that might be important, but for now I kept it simple, just drop to do in here. Then we have the other events. In the past episode, we just logged when those events were supposed to happen. In this case, we actually have the events, and again, not a lot. So for the user registered event, we just want the user ID and the username, which are user ID is, well, pretty obvious, and username is the only property that we are sharing with other services. For user updated, the same. So the user ID to know what user was updated, and username. So when the username is updated, this will be reflected here. Finally, user deleted, nothing other than the user ID, because we just want to say this user, get rid of it, we don't have it anymore. And that's it for those events. So in the outbox table, we will have always an instance of these events inheriting from the base out event. Now, mapping the changes to the events. So in the last episode, we created those iEvent detectors, which would go into EF Core's change tracker and map the changes into events. Now we just extend that concept to, besides detecting those changes, creating outbox messages out of them. So I changed the iEvent detector to an iEvent mapper. It's similar, so it continues to receive the DB context so it can detect those changes in the tracker, and it will return a collection of outbox messages. As we saw, normally we'll have only one, but just to keep things generic, it returns a collection of outbox messages. And it also receives a occur that. It's just a minor optimization, so we always put the same date time in all the messages, even though we'll probably only have one. So premature optimization, but let me be. Now for the implementation, we can go over here to the event mappers, and we have, like before, one mapper per type of event. Of course, this is not needed, but it's nice to have this separation, this clear separation. So, user updated event. This part of the logic is what we already saw in the past episode. So, we're checking if the user was updated, namely in the username property. If it is, we create a new outbox message with the time of the event, and for the user updated event, we just create a new ID where when did it occur, the user ID and the username for that user. So this is the same logic as before, and this is the small mapping from that change to the event that it will trigger. And the rest will be mostly the same. For the registered event, we have again the same logic, detecting the event, in this case where state is added, so registered means the user was added, and then mapping things to a new user registered event and setting things up. For the deleted event, and the same, detecting the change, in this case that the user was deleted, and mapping it to a user deleted event with the user ID. And that's all. So, and it's pretty clear with user deleted event does this, so it's not needed, but I like the separation. It's like using mediator. Instead of putting everything in the same service with a ton of operations, we separate with request handlers. In this case, we separate with individual mappers for each kind of event. Now, this is used where it was used, the detector in the auth DB context. Now, the usage is that. Let me just ignore this part. And so, where before we had the event detectors, now we have the events detected, which is a get events, which basically calls for all the mappers that we have over here. We inject all the mappers, and we do a select many mapping all the events, which again, it will be just one, but generic code because of reasons. And that's it. So here we have the events ready. Now, going back here to the topics. This is done, done, done. And now let's see transactionally storing the events. So it's a big name, but it's not a lot of work to do. So what I did here, let's open. Basically, these events in EF core and EF before it, everything that's done within the save changes by default is done inside the transaction. So we don't really need to do anything special. The only thing we need is to grab these events and add them to the change tracker. So going to the DB context, I could have done this .outbox messages .add range, but instead I used the set just because it's easier to mock if we really need it. Normally we don't, but if we need it, it's easier to mock this instead of the alternative. But it's just it. If there are events detected, we add them to the DB context. And nothing happens when we add them. It just stays in the change tracker. When you do the save changes, it will actually persist. Whoops. Okay. When we do this save changes, it's when things will be persisted. So the changes, in this case maybe a user registered, is persisted, and the event. So they are persisted inside the same transaction. So if something fails, everything fails, and we have reliability that we won't save things and forget to publish the events. And that's why we are using the outbox pattern to do this. So if we go over here, that's why we are doing this like this in the same transaction. And that's it. So it seemed that a transaction, something spectacular. Sometimes it is, but in this case we can just take advantage of what EF core already does, and by default save changes is done in the transaction. So we just need to have everything ready in the DB context when we save changes. And notice here the to do, which is for the next episode. After the changes are saved, everything is persisted. If something goes wrong, an exception will be thrown, and everything stops here. Otherwise, we can publish the events that were persisted in the outbox. But that's the topic of the next episode. Right now, we just put things in the database. So we can just take a look at this working. If this is working still. Site cannot be reached. Did I stop? Yeah. Let me just restart this. Let's go over here. And I'll rename the user to test1. Save. Now, let's go to the... This is to see in the database. We run the query and we have here an event. ID 25 because I've done stuff. Created that and the event. You can copy the event, go over here, and we have here the event. So notice that we have the type, and it's the first property because it's a JSON column. If it would be a JSON B, what happened when I tried was the ID moved to the first position, probably because Postgres infers, oh, this is the ID, probably it's important to be the first one to index or something like that. I don't know. I'm speculating. But by using JSON instead of JSONB, the order is maintained. So type is the first one, and it says it's a user updated event. So the deserializer will be able to deserialize this with no problems. And the rest of the information, user ID, the updated username, so test1, it was test, now test1, and the rest of the information, ID of the event, and when it occurred. And it's all. Now that we have things written here, in the next episode we'll implement the publisher, which will go to this table, read the messages, and put them in the event bus. And that's about it, about this topic. In terms of implementation, it's not super hard. Maybe sometimes we can forget parts, and again, like I mentioned in the past episode, and it's worth mentioning again, many libraries already implement these kinds of things, so most of the times probably we don't need to implement it, but I thought it would be interesting for us to look at this more lower level stuff. And that's it. As usual, if I went too fast or too slow or something like that, let me know. And if you have any questions, ask away. I'll try to help as best as I can, or provide ideas, because maybe I forgot something. But that's it for this episode. So we are storing things, like in the name, transactionally storing, and fulfilling this need of doing things in the same transaction. And in the next episode, we'll implement this part with a bit of this. Kinda. We won't really publish to the event buzz yet, but and that's it. Again, any question, feedback, remember to drop it. It's useful, and for questions I'll try to answer them on the comments, or eventually addressing them in future episodes. So hope you enjoyed it, and hope to see you in the next one. See yous!